Okay, so we have it's a big screen. Our next lesson for geometry. This is really like the third day. We're going to talk about circles. So remember, the first day was Pythagorean theorem. Then we talked about area and perimeter of rectangles and squares, and now we're going to talk about area and perimeter of circles. And the big question I want you to think about, and you see it a lot, and you might be wondering, how do we get this term pi? Like it looks like that. It's a Greek letter. It looks like that. What is that? What does that represent? So let's start there. Okay, I've drawn three circles, and they're all different sizes. And it's tough to do here. It's better to do in person with maybe like some yarn or something like that, or a string. But we're making do with what we have. And so what I'm doing is I'm drawing the center of each circle and a line from one side through the center to the other side. So I'm going to do that for all three. And hopefully you'll notice that the size of each one of these lines is different. And these are all what we call diameters, right? So this is a diameter. So the diameter is going from one side of the circle to the other side, but through the center. That is the diameter. And you might have heard of from the center to a side, and that's the radius. So the radius is half of the diameter. But let's not worry about radius right now. I just want you to focus on diameter. And so what pi is a ratio between going, I'm going to draw this in green, going across a circle and going around a circle. Okay? So I'm going to mess those two off again. So pi, I'm going to draw it in red. I think that'll show up better. The ratio pi is a ratio that goes around the circle. So it's a ratio of around the circle, which is the circumference, divided by going straight across, divided by the diameter. And what you would see, and I'm going to use black just to knock it off, if I were to somehow lift this blue line and then just kind of wrap it around, I would get to about here. Then I'd lift, I'd bring it, I'd get to about here. I'd lift, I'd bring it around, and I'd get to about here. And then there'd be like a little extra. So I see like a diameter, another one. So I can see that this ratio is greater than 3. And you could do the same thing on a smaller circle. So look at the middle one. Again, here is my across versus around. And if I were to divide it up, if I were to lift this middle piece and then start to lay it around, I'd get to about there. Then I'd have to redo it, and I'd get to about there. Then I'd redo it, and I'd get to about there. That's not quite right, but it would be a little more than 3. And we could do the same thing here. Here's my diameter. If I were to lift that up and lay it around, I'd get to about there. Then lift it up and lay it around, I'd get to about there. Then lift it up and lay it around, I'd get to about there. And in each part, it would be a little more than 3, regardless of the size of the circle. So you always hear this ratio of 3.14. In fact, it keeps going on and on and on. And then, if you remember from earlier in the class, we talked about irrational numbers. It keeps going on and on and on. It does not repeat and it does not terminate. So pi is an irrational number. But ultimately, pi is a ratio of the circumference of a circle divided by the diameter. And it's a constant number. It's always this 3.141 going on and on and on. Now, what the more common formula you see is to then take this, and instead of the diameter, remember we talked about really half of the diameter is the radius. So I could say my formula, pi, equals the circumference divided by 2 radiuses. And then if I cross multiply both sides by 2r, I'd get the circumference equals 2 times r times pi, but for whatever reason we write it 2 pi r. And that is the formula for circumference of a circle. Notice 2 is a constant, pi is a constant, and r is going to be a number that's going to vary circle to circle. But my distance around circumference is 2 pi r. For area, I won't derive that formula, but that is pi, again a constant, times my radius squared. Right? And that is my formula for area. But I think it's interesting just to know how we think about pi. Pi is just a ratio. Let's try a few. Circumference and area, remember we're going to need units. So I notice here that r is 9. So circumference is 2 times pi times 9, which would be 18 pi yards. Area is pi times radius squared, so 9 squared equals 81 pi yard squared. So again, circumference is 2 pi r. These should be in your notes. Area is pi r squared. I'm looking over here and I see this whole length is 7. That's my diameter, so I need just this part, which would be 3.5. So here, my radius is 3.5, and I'm going to go ahead and use my same formula as there. So circumference is 2 times pi times 3.5. Well, 2 times 3.5 is 7, so I'm going to get 7 pi miles. Notice, since circumference back up here on the top left, circumference is 2 times pi times r. 2 times r is the diameter. So if you ever have diameter, you can just say diameter times pi. That's the circumference as well. I could have just taken diameter times pi, 7 pi. Area is pi. This I do need my radius squared. So 3.5 times 3.5, 3.5 times 3.5 gives me 12.25. So I'm going to get 12.25, that's a decimal. And my unit is miles squared. Again, notice circumference as a unit of distance, area, units squared. Should have put miles. Not confused with meters. And so you can see number 3 and 4 are going to be similar. We can just set up the formula. Here I have my radius. It's 5.6. So circumference is going to be 2 times pi times 5.6. Remember, you can just leave it in terms of pi. That makes it easier. It's exact. You don't need to put in a 3.14. Just leave it in terms of pi. Area is going to be pi times 5.6 squared. And I'll let you do that math. Over here on number 4, I got 15. Well, if we look up above at what we did for 2 for circumference is 2 pi r, but it's also pi times the diameter. Well, here I have the diameter is 15. So circumference is going to be 15 pi. And don't forget my units, centimeters. Area is going to be pi times my radius, 7.5 squared. And I'll let you figure that one out. Why that? Because radius is half the diameter, right? Radius is my diameter divided by 2. So in this case, it's 15 divided by 2, which would be 7.5 squared. I want to do a couple of these word problems because these tend to challenge students a little bit, so I want to make sure we feel comfortable with them. If a circle has a circumference of 15 pi, what is its area? So in these ones, in order to find area, I got to have r. And right now, this problem doesn't give me r. It gives me circumference of a number, and I need to solve for r. So the circumference, we know the formula is 2 pi r, and in this case, they give us it's 15 pi. So I found this is the best way to set these problems up, is to remind yourselves that circumference, they give you a value, 15 pi. Just set that value equal to your formula. Okay, so over here on the side, we've got 2 pi r. Again, why are we doing this? Because we want to solve for r. we need r back over here to get area. So divide both sides by pi. That's going to cancel pi out. I got 2r equals 15. R equals 15 over 2, if you want to write 7.5. And then I'd plug this value all the way back in there to find the area. It's actually going to be the same number you found up here in number 4. Number 6. Now I notice if a circle has an area of 81 pi, what is the circumference? So for circumference, that's always look at the question. What is the circumference? Circumference is 2 pi r, but I need r. I don't have r right now. What I have is the area, which is 81 pi. And I also know that formula for area is pi r squared. So they gave me these two things, but I also know area is this. That's my formula. So that allows me to solve for r. So 81 pi equals pi r squared. Pi's cancel out. R squared equals 81. R is the square root of 81, which is 9. Okay, so I'm going to plug this back in here. So now circumference is 2 pi times 9 equals 2 times 9 is 18 pi. They don't give me units, so I'm just going to say, if you want, you just say units. Same thing up above. Okay. And then lastly, we'll just take a look. We're going to get to unshaded and shaded over the next few days, but this is an interesting one, if you look at number 7, to find the unshaded area of this picture. And I notice there's two shapes. There's a square and a circle. And if I want the unshaded area, it would be this big square. So I need the area of the square minus the area of the circle. I'm just going to take out this shaded area. And then I would have the unshaded area. Well, they give me a side. That's all they give me. That's fine. So for area of a square, I know area is side squared, which in this case is 8 squared, which is 64. Okay. No units. That's fine. I need the area of that circle. Well, if this side is 8, another side that goes right through the middle is 8, which means my radius of that circle would be 4. So the area of the circle is pi r squared, which is pi times 4 squared, which is 16 pi. Now we want to leave these in terms of pi, so I don't need to put in 3.14. So the area of the unshaded region is the area of my square, 64, minus the area of my circle, 16 pi. And then I could just say units squared. And that's going to be it for today. Hope everybody's doing well. Please send me an email or send me a note on Schoology if there's any questions.